And now we can look at our two examples of nested queries side by side, and we can figure out what they have in common and where do they differ. So what they have in common is that they're both problems that you cannot resolve with a simple query because you need to use values that you have to compute separately, values that you cannot simply refer to by name like we usually do with our columns. In this case, on the left, you need to know what are the minimum and maximum values for experience. And in this case, on the right, you need to know what is the experience of a character's mentor. And so we solve that problem by writing a new query, a nested query, and making sure that SQL solves this query first, gets the result, and then plugs that result back into the original query to get the data we need. There is, however, a subtle difference between these two queries that turns out to be pretty important in practice. And I can give you a clue to what this difference is by telling you that on the right we have something that's called a correlated subquery, and on the left we define this as uncorrelated subquery. Now, what does this really mean? It means that here on the left, our subqueries are computing the minimum and the maximum experience, and these are actually fixed values for all of our characters. It doesn't matter which character you're looking at, the whole dataset has the same values from minimum experience and maximum experience. So you could even imagine computing these values first before running your queries. For example, you could say minimum experience is the minimum and maximum experience is the max, and then you could imagine replacing these values over here, right? This will not actually work because you cannot define variables like this in SQL, but on a logical level, you can imagine doing this, right? Because you only need to compute these two once. I will revert this here so we don't get confused. On the other hand, on the right, you will see that the value that is returned by this subquery needs to be computed dynamically for every row. This value, as you also see in the results, is different for every row because every row references a different mentor ID. And so SQL cannot compute this one value here for all rows at once. It has to recompute it for every row. And this is why we call it a correlated subquery, because it's connected to the value that is in each row, and so it must run for each row. And an important reason to distinguish between uncorrelated and correlated subqueries is that you can imagine that correlated subqueries are actually slower and more expensive to run because you're running a SQL query for every row, at least at the logical level. So this was our introduction to subqueries. They allow you to implement more complex logic, and as long as you understand it logically, you're off to a great start. And then by doing exercises and solving problems, you will learn with experience when it's the case to use them.